We're about to test the landing light. Spen's in the cockpit and he'll be operating the lights. The lights are coming down now. The lights are retracting. The lights go up about 45 degrees before the horizontal. As you can see, only one landing light is working at the moment. The inner one will have to be taken out and serviced. This is Spen, who has been operating the landing lights. Thank you. Jack's still waiting for the stiffeners to complete the hard riveting of the frame. But started putting the skin on now. It's very noisy in here again, isn't it?
Yeah.
Yeah. So what is this you've got in your hand then?
Right, this is the number 2 tank sender. Yeah, fuel gauge tank sender. So you've got the float arm running through a few gears, and in the top here there's what they call a DESIN transmitter.
A what transmitter?
A DESIN transmitter. D-E-S-Y-N, DESIN transmitter.
And what does that do? You don't need any wiring then?
Yes, there's 5 wires go in the top there. In fact, if you give me a couple of minutes, I'll connect it up to the test set and you can watch it work.
Oh.
Right. So I've connected it up to my test set, so we're looking on this, we've got it set to transmitter, because that's the transmitter, and it's swiveling on that nose there. So as I move the float up, so that meter should move round.
So is the tank in the full position now, the sender?
The tank would be in the full position now. Well, I think looking at the sender you'd be about there.
Oh, it fits in the top of the tank.
That's right, and then sort of as the fuel drains down, so it's a bit like in your car.
Yeah.
Similar sort of thing in your car, but I suppose a little bit better made.
Yeah. And does that need to go in before you put the tank in?
Not necessarily. It's a big panel on top of the wing where they can actually get it. I mean, when they've got it in, I'm going to have to get it on the wing to wire it up through this panel on the wing anyway. So,
Well, I mean, there must have been, knowing how much fuel was in the tank when they've been on the taxi run, so...
Yeah, I think they were using a dipstick.
Oh, I've seen Keith doing that.
That's right, yeah, they were using a dipstick. So we're trying to get them to come into the 19th century.
Yeah. Keith, how long will it be before you start drilling the wood? Oh, he said about another week. He said he's got to fit all the panels correctly first.
Yeah, that's right.
Because you can't make a mistake on that, can you?
No.
Gerard, the engineer, is going to talk us through it and show it how it operates. He's servicing the port side outer one at the moment. This is the airbag.
That's the bag. So the pilot applies the brake lever, and compressed air goes in through the brake relay valve, down the pipelines, into that connection there, into here, and inflates the bag.
How much inflation does the bag? Does it come out much?
It's limited by the diameter of the drum, and then you've got this retaining strap. These tongues go in through these slots, and then that secures the pad inside the drum. And then you've got two springs. So these springs are located on these spigots here.
I see, yeah. Two push
and these
the air.
dimples there. So
Yeah.
when the pilot releases the brakes, the action of all the springs pull the shoes back in, compress the air, squash the bag, and then the air goes back up the pipeline exactly the same way it came, and then it's exhausted through the brake relay valve.
Well, very simple idea,
Very
isn't it?
simple, yeah.
Yeah.
Generally normally very reliable. The only problem is if these become age hardened, or when the brakes are hot, if the pilot leaves the brakes on, the heat from the brake drum builds up through here, it's transferred to there because you haven't got an air gap, and then eventually it can cook the bag.
I see.
But these are pretty good, loads of meat on them,
Yeah, they're still good, aren't they?
no cracks from the rivet holes.
Yeah.
Got to examine all these lugs.
That's how we used to rivet the old cars on in the 50s.
Exciting.
Used to buy the shoe pads and the ferrode out and just rivet them back on.
These nuts and bolts. These ferrule nuts go in that way. Once this is in place on the axle, so you stick your hand down the axle, and then the bolts go radially from the inside out, and then screw into your ferrule nut. So then that's your torque plate bolted to the axle.
Very good. Very well manufactured, weren't they?
Yeah. So
And they're all your bits and pieces. Oh, I see. Just cleaning those up, are you?
cleaning those up at the minute.
Was there any trouble with it? The brake? Did you? Of course, you said you didn't know because you hadn't operated the brakes before.
No, I haven't personally.
No.
I think the pressures were set too low, but just look at the book. Then it'll be a question of tweaking the valve up, the operating mechanism to get the book figures.
So the air cylinder, what sort of pressure does that have in it for the brakes?
The XL's wartime pressure, the brakes were working at 80 psi.
Yeah.
PA474 down the road, she works, when I was on it, used to work at 120 psi.
Why would they move up when they're carrying less load? I mean, wartime would be fully laden and with only 80 pound pressure.
Yeah, but you weren't putting your brakes on taking off.
Well, that's true, yeah.
You were using, in the main, you were using your throttles and your rudder to, once you got the arse end up, so the rudder and elevators have got authority, you were using your rudders to steer and the throttles.
Yeah.
But somewhere in here, if you want the diagram, compressor.
Yeah.
But if you're on the ground and you want to top the bottle up, you've got the ground charging point, and then you've got your pressure regulator valve. So depending what that's set at, could be 400, 450 psi.
Yeah.
That'll allow that to charge that up until whatever pressure that lets go at. Then you've got your oil and water trap here, your filter, which this happens to be, that's a pneumatic filter in component form there. Then down to your brake relay valve.
See, this air pressure bottle, that's just in front of the pilot situated, isn't it?
That's right, it's between the back of the nose turret and the front of the instrument panel.
Yeah.
And that's his brake operating cable.
Yeah.
And then you've got a connection on there which goes to the rudder bars. So as the pilot moves his rudder, if he only moves his left foot forward slightly, you'll only get, for argument's sake, 40 psi.
I see, yeah.
And so it's a differential braking system.
So is he turning right or left?
Whichever way he wants to turn.
The brake comes on the opposite side?
No. If he wants to turn left, he'll put his left foot forward, so that'll move the rudders over to the left because you're using airflow as well.
Yeah.
And that'll apply the
brake. That's right, yeah. And that'll allow the starboard side to swing round.
Yeah.
Oh, good. Thank you very much. Very interesting, that.
Oh, that makes sense.
Yeah.
So you literally got, when the bag swells, you've got that distance there, and that's limited by
that bracket, yeah.
how far that strap would go. So that's what stops it. So you're only talking about that sort of distance there.
Yes, yeah.
Not even probably quarter of an inch.
No. Oh, right. That's very good. Thank you very much.
Right, look.
Numbered in the right order to go back.
That's it.
If I switch the camera on, it might help.